right, we're going to talk about how to sketch graphs of rational functions. Now, there's several steps on how to do this, and we're going to go through them and identify all the key features of a rational function graph. The first thing is when we want to find a rational function, there are several key features. So first off, we're going to have, and want to find the x-intercepts, or zeros of the function. Okay. The next thing is we want to find the vertical asymptotes. All right, vertical asymptotes. All right, I'm going to find the horizontal asymptotes. Horizontal asymptotes. And also slanted asymptotes if there are any, but we'll just start with this. And also what we want to do is we want to identify any holes in a graph if there happen to be any. Okay, so holes. Okay, so as we go through, let's first identify the x-intercepts. Now with the x-intercepts of this particular function, all right, whenever you have a rational function, the key thing is to understand that you have a fraction. And so when you're looking for the x-intercepts, or the zeros, you're setting the function equal to 0. Now, when is a fraction equal to 0? Well, the fraction is equal to 0 when a numerator is equal to 0. So in this case, we're going to take 3x, which is our numerator, and set that equal to 0, and identify we have x-intercepts at 0 at the origin. So over here, I'm going to plot that graph right away. All right, create my grid right here. And I'm going to plot at the origin 0, 0, and that's where we have our x-intercept. The next thing we want to do is we want to identify vertical asymptotes, or holes. Now, holes are undefined values, defined values, all right, that you can identify them because they have a common factor, all right, common factor in the numerator and denominator. Now, in this particular problem, we do not have a common factor, so there are no holes in this graph. However, there are some vertical asymptotes because vertical asymptotes are also undefined values. All right, undefined values. There are no common factors, in the numerator and denominator. And because they're undefined, we're going to take our denominator. All right, and how do we find this? We take our denominator and set that equal to 0. So in this case, we're going to go set the denominator and set that equal to 0. All right, so I have x squared minus x minus 2. I'm going to factor that, x minus 2 and x plus 1. And we'll set that equal to 0. So identify I have vertical asymptotes right here at 2. So I'll graph this at 2. All right, and at -1. -1 right here, like so. All right, now that we've found our vertical asymptotes, the final thing we want to do is we want to find our horizontal asymptotes. Okay, horizontal asymptotes. I'll bring this over here and put it right like that. Okay, horizontal asymptotes are located where our we're looking for end behaviors when x approaches infinity and when x approaches negative infinity. Now, to do this, a lot of times what we can do is we can compare the degree of the numerator and the denominator. So if you look at this degree, you notice that we have a degree of 1 in the numerator and 2 in the denominator. So that means the degree in the denominator is greater than the numerator. Now, because we're going to infinity and negative infinity, that means, and since this is a fraction, if the denominator is greater, all right, that means the denominator is going to be increasing and producing a smaller fraction. Because we're producing a smaller fraction, our horizontal asymptote is going to equal 0. All right, so right here, we're going to actually have a horizontal asymptote at 0. Now, I'm going to place this horizontal asymptote at the end behaviors because that's what we do with horizontals. All right, and we have that. Okay, from here, we're now going to graph, all right, our function. So if you notice there, we have a bunch of different regions. We have a region here, I'll call it R1. We have another region between the vertical asymptote and this other one, which is called R2. We have another R3 and R4. We're not going to say R3 or R4, I think of R2D2, but that's just me getting off topic. Okay, now from here, in order to figure out what is happening at each one of these values, you can use your calculator, or we can do some test points, okay? Find some test points. Now, I'm going to move some of this stuff, all right here, and put this down over there so I have a little bit more room, okay? And so I'm going to test some of these values. So right here, I'm going to take this region 1, and I'm going to test the value over here. So if I want to test like -2, I would take a -2 and plug it into this value and find out what we have. Well, -2, when I plug in here, it gives it a negative value. Then I have another value, and I plug in -2. All right, and because this is going to be simplified, and I guess I will simplify this. This right here is going to be x minus 2, and then x plus 1. Okay, we can see that when I plug in -2 here, I get a negative, then negative makes it positive, and so what I have is a negative value. So what's happening is this is going to be decreasing, like so, because we have a negative value if I plugged in a test point in this region. Okay, x equals -2 gives me a negative value. Then I plug in a value over here, and that could be like -1/2. -1/2 gives me a, all right, negative value, so x equaling -1/2. All right, plug something in there, negative value, we get a negative value and a positive value. Negative or negative is a positive, so I have a positive value here. Guessing this is going to probably pass through. Plug in a 1, like x equaling 1 into this region number 3, just to see how that works out. We get positive, negative, and then a positive, so it's going to be a negative. And then finally over here, I'm going to plug in another value like 3. All right, we'll do a test point of 3. We get a positive value, plug it in here, we get a positive and positive. So it's going to be positive, positive, like Mary Poppins. And we have our sketch of our graph. We just went through on how to graph a rational function. By doing so, we reviewed how to find x-intercepts by looking at the numerator, because that's when our function will equal 0. We identify where holes are. That is where undefined values, and you have a common factor in numerator and denominator. We identified vertical asymptotes, which are also undefined values, but there is no common factor, and so we set the denominator equal to 0 and sketch those. Horizontal asymptotes are m behaviors, where x goes to infinity or negative infinity. And we compare the degrees when we have a rational function and try to determine which one grows more. If the denominator grows more, then we know we are approaching 0 because we have a smaller fraction. And from there, we can plot our respective values and then test our points in our regions, all right, between the vertical asymptotes and the zeros to get a sketch of a graph. All right, this is our first example. There's going to be several more coming up, but hopefully this helps.